Exercise number 12G, for which values of fx is increasing. So we want to find which value that this graph is has a positive gradient. Increasing means positive gradient for some value. So this graph has positive gradient. So we want to find which values for this in this x-axis. So first of all, let's find the gradient. And if dash x equal, we know this is going to be 6x plus 8. Now we'll find uh, now this from this curve we'll find where this curve, not this curve. No, this is a different curve. We are going to tell about this curve by looking at the gradient curve now. So f dash x equals 0, or will come like this. So f dash for which value of x is increasing. So in this graph, f dash x has to be greater than 0 or equal to 0. Now we have f dash x. Uh, what is this f dash x? It is a line. So now this is x and f dash x y-axis, and this is 6x.8 when x equal 0. So it has a positive gradient, and it's going like this. Now which area f dash x? F dash x means y value in here. Y value is positive in which area? The y value is positive in from here to in this. This is positive. Can you see? So it means from this place onward, the y value is positive. This place onward, y value is negative. Can you see that? If you take a point and draw, say it is in the negative area. So here, if you take point here, and you can see this is above the line. So this is all pluses. Above the line plus, below the line negative. So f dash x negative in this area. Do you know this value? How do you find this value? Right, this is if you make equal to 0, in here f dash x equals 0 or y value equal, you can take as y as well. F dash x equals 0, 6x plus 8 equals 0, x equal minus 8 over 6 minus 4 over 3. So this value is minus 4 over 3. Now you can see that the f dash x value is all positive after x greater than minus 4 over 3. Or you can write like this as well, minus 4 over 3 greater than x, f dash x greater than or equal to 0. Or you can work out like this, um, f dash x, yeah, you want to make it equal to 0, and then there are two areas in the number line, minus 4 over 3. So one is less than minus 4 over 3, other one is greater than 1 over 3. Now when you look at x less than minus 1 over 3 and x greater than okay, minus 4 over 3 greater than x, left side and right side. So what will happen to the 6x plus 8 value? In here, when you take any number minus 10,000, if we put minus 10,000 is less than minus 4 over 3. So if you take minus, okay, let's say 1000, When you put minus 1000, what is the value here? This value is going to be negative. If you put anything above minus 4 over 3, what will happen? If you put 0, it is also above. One value from this side, that's enough. 1 is enough. This is going to be positive. So now what is this 6x point mean? F dash x. F dash x is positive into minus 4 over 3 greater than x. Hence, function is increasing when minus 4 over 3 greater than x. So having this knowledge, you can do like this. So you have f dash x equal 6x plus 8. Function is increasing if f dash x greater than or equal to 0. So what is x dash x now? 6x plus 8 greater than or equal to 0. Then this is going to be 6x greater than or equal to minus 8. X is greater than or minus 8 over 6. X is greater than minus 4 over 3. So minus 4 over 3 greater than or equal to x. Y equal 4x minus 3x square. I'll take fx. So in this curve, some area, we can see f dash x greater than or equal to 0. That is the area we need to find. Now we want to find part 2 for which value f dash x is greater than 0. Now f dash x is 4 minus 6x. So this is the behavior of f dash x. This is a line with a gradient negative gradient. So f dash x greater than or equal to 0 we required, minus 6x plus greater than or equal to 0. So 4 greater than or equal to 6x. So 4 over 6 is greater than or equal to. So 2 over 3 greater than or equal to x. Basically, x greater than or equal to 2 over 3. That function when x fx is increasing. So part C, fx is given. We'll find f dash x. This is going to be 8 minus 4x. Function is increasing when f dash x greater than or equal to 0. It means minus 8 minus 4x greater than or equal to 0. Minus 2 greater than or equal to 4x. It means minus x. This is positive x. So x, when you take the number line, this is minus 2. So all the value less than minus 2 will, the function will increasing. For all values of x right, minus 2 x less than or equal to minus 2, the function is increasing. Or you can write for fx is increasing, fx is increasing for x less than or minus 2. 2x cubed 15x square plus 36x, and we'll find f dash x. This is going to be 6x square minus 30x plus 36. I think I can factorize with 6x square minus 5x plus 6. Now we want to find for which value f dash x is greater than 0. Let's see whether we can factorize this one. X minus 2x minus 3. So yes, we can factorize this one. Now we can break this area f into 3. Initially we will make into 0, then x minus 2 equals 0. It will give 6 times x minus 2 x minus 3 equals 0, so x equal to x equal 3. So we are going to break this number line into 3 pieces, 2, 2 to 3 and more than 3. So then here f dash has to be greater than or equal to 0. It means 6 times x minus 2 x minus 3 greater than or equal to 0. Now we want to find for which value this is greater than or equal to 0. So basically we can check the numbers. Okay, 6 times x minus 2 x minus 3. I will write this is x great less than 2, this is 2, x this is 3, and this is 3 greater than x. So those are the 3 areas, and we will check 6 times this one, 6 times this one, 6 times this one, right? Now how do we check? So we have the number line 2, 3, 2, this is 3, and take any number less than 2. So let's say less than 2, 0 also less than 2. If I put 0 here, this one is become negative, 0 minus 2 negative, 0 minus 3 also negative. So negative times negative is positive, multiplied by 6 is still positive. Right? Now we'll check this one. If you take any number from 2 to 3, 2.5. If you put 2.5, this is positive. If you put 2.5, this is negative. Then plus times negative, positive times negative is negative. Sin 6 is still negative. Now if we put more than 3, let's say 10, 10 minus 2 positive, 10 minus 3 positive. So 6 times positive is positive. Now you can see this is f dash x. So which area that f dash x is positive? This area and this area. So then our answer is fx is increasing when x less than 2 or 3 greater than x and 3 greater than x. f dash x is, this is 3, and this is 6x and 3x square, and f dash x is 3x square minus 6x plus 3. I just this one, and I can see 3 is common, x square minus 2x plus 1. So this is 3x minus 1 square. Now, what you can tell about this x minus 1 square? You can tell this x minus 1 square is positive. For which values? So I will make f dash x equal 0, then x minus 1 equal 0, x minus 1 equal 0, x minus 1. So x equal 1. Okay, this is 1. So we have identified two areas, one less than and x less than 1, 1, 1 greater than x. Take any value from here. Let's say minus 10. When you put minus 10, do you get positive value or negative value? X equal minus 10, 3 times minus 10 minus 1 square. So this is greater than or equal to 0. If you take positive from this area, when x equal 10, 3 times 10 minus 1 square, 9 square is still greater than 0. It means if you take any value from number line, both side it is positive. It means if you take any value from this number line, this is greater than 0. You can tell that 3 minus x square is greater than equal to 0 for all x. Hence, function is increasing for all x. Our function is increasing for all real numbers. You can write this one, real numbers, member of real number. X is a member of real numbers. X is an element of real numbers. So this is the function. We'll find f dash x. So this is going to be 15x square plus 12. The function is increasing if f dash x greater than or equal to 0. So f dash 15x square plus 12 is greater than equal to 0 for all values of x. Can you tell put any x value? We have two x values. One is positive, other one is negative. When you put x negative, it is greater than 0. When you put positive, it is greater than 0. Hence, for all values of it is greater than equal to 0. Sorry. Hence, function is increasing for all value of x. You can give argument if you want here. So x can be any number equal to 0 greater than. So x square is greater than or equal to 0. When you square, it can't be negative. Then when you multiply by 15x square, still negative. Then when you add 15x square plus 12, it's still negative. greater than 0. I will do like this. So 15 x square equal 15 times 0, which is greater than equal to 0, because I'll rewrite. Now I'll add both sides to 12. Now this is 15x square plus 12 greater than 12 is definitely greater than 0. So 15x square plus 12 greater than equal to 0. So what is this one? Hence f dash x greater than equal to 0. So this is, I give a proof basically. I realize when I look at this one, this is going to be a positive number. Always. G fx equal x4 2x square, and G f dash x equal 3x cube 4x. Sorry, this is 4x cube 4x. Then when I take this one, I can take 4x out. It's going to be x square plus 1. Now when I look at this one, for x equal minus, for x equal positive, this is always positive. But if x is negative here, x can be negative or positive. So this is always positive. So negative times positive, negative. Positive times positive, positive. Hence, if dash x is greater than equal when x greater than 0. When you look at this one, you can see that this part, x square, for any x value, x square is positive. When you add to positive, it is positive. Then this f dash x not depend on this one. It depend on in what? Depend on is this variable x. If x is negative, f dash x negative, x is positive, x dash is positive. So hence we'll get the positive. Still, if you are not sure, put x negative value. So this f dash x going to be negative. Put any x positive value, then it is going to be positive. Basically, the function is positive for all positives. F dash is greater than when x greater than 0. Hence, if x is increasing when x greater than 0, or we can consider equal to 0 as well. When x equals 0, this value is 0. If you want to write something on it, that you can do x greater than 0 and x less than 0 and x greater than 0. This is also same the value. So this is 4x plus x square plus 1. When you take negative number, this is positive and this is negative and this is 4. Overall is negative. Right? When you take a positive number, this is positive. This is always positive because we take the positive because of that positive. Positive times 4 is still positive. So then x greater than 0 positive. Hence x less than 0, this is x equals 0 and x greater than 0. So this is greater than or equal to. We'll find f dash x. So this is 4x cubed, then this is 8 times 3 times x square. This is going to be 8 times 3. 24x square. So 24x square. So I can see 4 common, x square common. This is going to be x minus 6. Now my question this x is depend on positive and negative values. If I substitute for x square positive, still it is positive. If I put negative, still it is positive. So basically f dash x not depend on this, because this is always positive. Whatever the value you submit, this is positive. Right? Now what will happen? X minus 6. So when x equals 6, so what will happen when x minus 6 is 0, x equals 6? So what will happen if we put less than 6 and more than 6? If it is less than 6, what will happen? This is become negative. Select any value less than 6, this part become negative. Then the result is when x is less than 6. So plus times minus is negative. It means f dash x less than 0 in here. X greater greater than 6. Okay, x equals 6 if you want, then this is definitely sorry, x equals 6. This is going to be 0. It is going to be still positive, and f dash x greater than 0. This is x equals 6. Now x greater than 6 will put positive value. 4 as it is, this is not always positive, and this one, if I put 30, any value greater than 6, so let's say 30, 30 minus 6 positive, so it is positive. So then positive times positive, positive, and f dash x greater than 0. Hence f dash x uh, greater than 0 when x greater than equal to 6. Hence fx is increasing when x greater than or equal to 6. For this is different. For fx is increasing when f dash x greater than or equal to 0, which is 4x square 6 minus x greater than or equal to 0. Now x square greater than or equal to 0, 4x square, hence x minus 6. I will divide 4x square from both sides. Then x minus 6 greater than or equal to 0. Then x greater than or equal to 6. So this way you can take the answer, kind of a organized answer, but you should know what is going on, like the real idea. X square is positive because of that. This term is depend on only this one. So then we realize that there are we can number line break into two part. One is less than 6, another one is greater than 6. If it is greater than 6, the f dash is greater than 0. That's all. So fx is x square minus 9x. So then f dash x is 2x minus 9. So this is not increasing, so this is decreasing. Fx decreasing when f dash x less than 0. What is f dash x mean? 2x minus 9 less than 0. It means x less than 9 over 2. X less than 4.5. And fx decreasing for all values of x less than 4.5. Fx is 5x minus x squared. F dash x is 5 minus 2x. Now fx is decreasing when f dash x less than 0. So it means 5 minus 2x less than 0. 5 less than 2x, 5 over 2. So this is 2.5. So all the values of x which is greater than 2.5, the function is decreasing. Fx is decreasing for all the value of x like that 2.5 less than x greater than x. For all the value for x greater than 2.5. If dash x is minus 2 minus 2x. So if x is decreasing, if dash x less than 0, it means minus 2 minus 6 less than 0, minus 2, 2x, or 2 to 2 cancel out, minus greater than, minus 1 greater than x. Hence, if x is decreasing for all the value, decreasing for x greater than minus 1. If dash x is 6x square, 6x minus 12. Now, when I look at this one, there are more than two intervals, not number line divided into two pieces. This is a quadratic equation, so I am accessing three pieces. Then I have to assess it. If dash x, when you take 6, x minus x square minus x minus 2. So f dash x equal 6 times x minus 2, x minus 1. Now I can see that this is, it has x equal 1 and x equal 2, right? So I want to assess what will happen less than x less than 1, then 1 greater than x greater than 2, and 2 greater than x. If x less than 1, take any value less than 1. Let's say minus 100. So then this is going to be 6 minus 100 minus this is negative, and this is negative, minus 100 this is negative. So overall value is negative. Hence f dash x less than 0. Sorry, positive. Negative times negative, positive. So this is greater than 0. If 1 greater than x greater than 2, what will happen? In between 1.5. So this is 6. 1 minus 1.5, minus number. This is 1.5 minus 1, positive number. So this answer is going to be, answer is equal to a negative number. It means f dash x less than 0 if you select this area. And if x greater than 2, you can write 2 greater than x. So select 100. So this is 6, and 100 minus 2, 98 is still positive. 100 and minus still positive. So this is going to positive. F dash x equal greater than 0. Now, which area is, now you can see f dash x less than 0 when 1 x greater than 2. So hence f(x), the function is decreasing when 1 greater than x greater than 2, or the function is decreasing on the interval 1 greater than x less than 2. F dash x equal minus 27 plus 3x squared. Let's do a research on this one. When x equal minus 2, what is the value of f dash x? Greater than or less than? So minus 2 is square 4. 4 times 2, 4 times 3, 12. Minus 2 and it is less than. X equal minus 3. So fx minus 3 square 9. 9 times 3, 27. Okay, it is equal to 0. X equal 4. F dash x. 4 square 16. This is 40. So this is greater than 0. What will happen? X equal minus 4. X equal minus 4. Again, it is greater than 0 here. So it is varying. Basically, minus 3 to plus 3, it has a negative value. Less than minus 3 or more than minus 3, this function is going to be positive. F dash x equal 3x square minus 27. F dash x equal, when I take 3, this is x square minus 9, which is 3 times x square minus 3 square, which is f dash x is 3 times x minus 3, x plus 3. Now you can see that this number line is going to be 3 minus 3 and 3. So there are 3 areas. X equal less than minus 3, minus 3 greater than x greater than 3, 3 greater than x. Because when you equal to 0, you will see this. Now, if x less than minus 3 in here, so can you tell any number less than minus 3, minus 100. So minus 100 minus 3 minus. Total value is minus 100 plus 3 is still minus. Minus times positive, positive times 3 is still positive. So this is equal to positive. So f dash x greater than 0 here. If minus 3 greater than x greater than 3 in between. If we put, can you tell me any number between minus 3 and 3? 0. So 0 minus 3 is negative. 0 minus 3 is minus 3. That is negative. 0 plus 3 is plus 3. It is positive. 0 minus 3 is minus 3. So that's why it is negative. So this answer is negative. So f dash is less than 0. If x greater than 3, 3 greater than, if we put 100, 100 minus 3, 97, which is positive. 100 plus 3, 103 is still positive. So this is positive. Positive times positive is positive. So f dash x is greater than 0. Now this is the only possibility. F dash x is less than 0. F dash x less than 0 when x is in between minus 3 and plus 3, which is minus 3 greater than x greater than 3. Hence fx, not f dash x, hence fx is decreasing on the interval of minus 3 greater than x 3. Question number f, fx equal x plus 25 over x, which is x plus 25 x minus 1. Then f dash x is, this is 1 plus 25 minus 2 x minus 2, which is 1 minus 25 x minus 2, 1 minus 25 over x square. Now f dash x equal 1 minus 25 over x square. If I take x square out, this is going to be x square minus 25. When you multiply by back and see that whether you will get the same answer. I take 1 square out, or 1 minus 25 x square. So write x square over x square is still 1. Then you can take 1 over x square out. Then that is x square minus 25. So then f dash x equal 1 over x square x minus 5 x plus 5. Because I can write this is 1 over x square minus 5 square. This is difference of two squares. Now I can see whatever x, if you put minus, this value is positive. And if you put positive, still this is positive. So this is always positive for any value. Hence we can disregard this part, and actually this is minus 5 and 5. We can break into this number line minus 5 to 5. X minus 5 plus x5 equals 0, x equal 5 or x equal minus 5. Now let's discuss the behavior of f dash. When f dash, when x, okay, if x less than minus 5, somewhere here, let's say minus 10, this value always positive, this one. This is negative if it is minus 10 minus 5 minus 15. Minus 10 plus 5 is still negative, and negative times negative positive. So f dash x greater than 0. Then this area. If minus 5 greater than x greater than 5, what is the number? 0. Now we know this is always positive, and okay, I'll take different number. I can't take 0 because 1 over 0 is infinity. So let's take 0.1, 1. So 1 minus 5 negative, 1 plus 5 positive. Negative times positive, negative. So this will imply if there's x less than 0. Then if 5 x greater than 5, this area. Let's say 10, when you put 10, this is always positive. 10 minus 5, positive, and 10 plus 5 is still positive. We don't need to bother about the numbers. We are checking whether this is positive or negative. We know this is always positive because x square. X square is positive, 1 over x square also positive then. So this is positive, hence f dash x greater than 0. Hence, one more thing, this sum is not exist when x equals 0. 25 divided by 0 is infinity. Basically, we need to give this within sum x not equal to 0 because x equals 0 is asymptote. Now, hence, f dash x equal less than 0 when fx is minus 5 greater than x greater than 5 in between. Hence, fx f dash x when minus 5 greater than x greater than 5 but x not equal to 0, but x not equal to 0, or you can write like this as a two interval minus 5x greater than 0, 0 greater than x greater than 5. So in here 0 is not included. Hence fx is decreasing on the intervals of minus 5 x0 and minus 0 greater than x greater than 5. And you remember when we do graph, if we have a asymptote, we also get that asymptote into the consideration. Chapter number 4. Question G, if x equal x half plus 9x half. So square root x 9 over square root x. Now, what will happen? X is negative. So minus square root not defined. It means x equals 0 also not defined. 9 over 0 infinity. It means this function is not defined for only defined, not defined. Let's say only define x greater than 0. When you see a function, you want to look at that what kind of x values in general it's going to work. So if you look at x square root, then definitely no negatives. For negative numbers, this function doesn't work. And also 1 over x or x square root x, 0 also it doesn't work. So f dash x is half x minus half, and this is 9 minus half x minus half minus 1. So this is 1 over 2 square root x. This is 9 over 2, 1 over x, 3 over 2. Alright, this is x half as well. If I take 1 over x 3 over 2 out, Then this is going to be x 2x. I can take 2 as well. So I can take 2 as well. So this is going to be x square minus 9. Sorry, this is not x square. This is x9 minus 9. If you are not sure, you multiply by n. Take. So what is happening in here? Basically, 1 over half x half minus 9 over 2. Can I write x half a times x 1? So that is 1.3 over 2, 1.5. I write differently. Now you can see 1 over 2 x half, I took it out. So then here it is going to be 1 over 1 minus 9 over x. Then I want to take x out. So I will make x like this. 1 over 1 is 1. 1 divided by. So x divided by x also 1. Now I'm denominator is same. So then 2x half times x. Then this is x minus 9 remain on top when I take 1x out. So this is become 2x 1 plus 1 half 3 over 2. Now f dash x equal 1 over 2x 3 over 2 x minus 9. Now we have f dash x, this one, and we know that x has to be greater than 0. And now when you look at this one, I can see that x minus 9 is breaking at 9. No, those are the two intervals I can say. What will happen? 0 greater than x greater than 9 from here to here. This is going to be positive always, this term, and this term is going to be negative because if you put 5 minus 9 is minus. So then this is less than 0. It means f dash x less than 0. So it has a negative value. 9 greater than x greater than infinity, or 9 greater than x. This is plus always. And this value is plus. So plus times plus plus f dash x greater than 0. Hence f dash x less than 0 when on the interval of 0 x 9. Hence fx is decreasing on the interval h. Fx equal 4 minus 2x cube minus 3x. X is element of 2x cube minus 3x. Now f dash x equal, this is 0, this is 6x square minus 3. So f dash x equal, if I take minus 3 out, this is going to be 2x minus 1. I think I'm working in wrong sum. It has to be in this one, h. Fx equal x square x plus 3. So then if x equal x cube 3x square. So if dash x equal 3x square plus 3x, when I take 6x, 3 times 6x, when I take 3x out, this is going to be x plus 2. Now I can see that three areas x equals 0, x equals 0 and x equal minus 2. So this is minus 2 and this is 0. There are three intervals we have to consider, right? So minus 2 greater than this area, x greater than minus 2. Then this is 3 and this x is become negative if you put minus value here. This is also become negative. This is going to be plus. So if dash x equal greater than 0. Now if we put minus 2 greater than x and 0, this is 3 as it is. This is going to be minus and this is going to be plus. And this is negative and f dash x is less than 0. And this is x greater than 0. So this is 3 positive, positive and positive. So f dash x less than 0 when x is in between minus 2 and 0. Hence function is decreasing on the interval of minus 2x 0. This is question number 3. We'll take fx is still simplify 4 minus 2x cube plus 3x. When I take f dash x, this is 0, this is minus 6x square, this is going to be plus 3. Sorry, this is minus 3x. So this is minus 3. So this is going to be minus 6x square plus 3. The argument 6x square plus 3, you can see when you put any value for this is become positive. X square is positive and this whole bracket is positive. Plus 3 greater than or greater than 0 always, not equal even. To 0 for all values of x. But minus 6x square plus 3 less than 0 for all values of x, because when you multiply by minus, always minus. Hence, f dash x less than for all values of x. Hence, fx is decreasing for all value of x. You know that positive value when you multiply by negative, it's become negative. That's why. Question number 4. Function is increasing. This function is increasing in between minus 1 and 1. This function is increasing in between minus 1 and 1. So first of all, get the gradient function. This is 2x plus 3. When x equal minus 1, we'll take the left boundary. This is a boundary minus 1 in between minus 1, x and 1. So this is one lower boundary, this is upper boundary. So then x equal minus 1, f dash x greater than 0. So 2x plus b greater than 0. So x is minus 1. So 2 times minus 1 plus b. So then b greater than 2. Then we go to right boundary. When x equal 1, 2 times 1 plus b greater than 0. b greater than minus 2. Let me take the equal sign as well, because f dash increasing mean greater than or equal to. When x equal 1, 2 times 1. So now we have two options. One is this is p. One is minus 2 greater than 0. The other one is 2 greater than 0. Then this inequality will fulfill both inequality when p greater than 2. Both this plus is increasing when minus 1 greater than x greater than 1. So you can write when x equal minus 1, f dash x greater than or equal to 0. Hence 2 times 1 plus p, so p equal minus 2. So this is part b. This is when x equal, it means at lower boundary. This is x equal 1 not minus 1 at upper boundary. When x equal 1. So